Hello and welcome. I'm Mr. Olson. This is going to be our homework help video for linear regression with a calculator. For this, we're going to need a TI-83 or newer calculator. We're going to put our data into our calculator and calculate a regression. Let's start with problem number 1. Households consume much more electricity when the weather is warmer. And we can see that in our data, but maybe we shouldn't even believe this sentence until we've had a look at the data ourselves. So, first thing I need to do is I need to get that data into my calculator somehow. So I'm going to start with a blank screen. Wherever I'm at, I'm going to press second mode to bring it back to a blank screen. Next thing, I need to get that data into my calculator, so I press stat, the button that just lit up in red there, and then press enter, and that brings up my stat list. You can see that I've got some data already in here, so I need to clear that out. I can go up to the top and press clear, enter on each list. Or there's some other methods for clearing it out, but that works pretty quickly. So we'll just go with that method. Let's enter our temperature data in for X1, 56, 64, 73. Pressing enter between each data point as we enter them. All right, and for our Y values, we want to make sure those are lined up exactly across from the X value they're correlated to. Make sure there's no extra data points at the end, or else you get a dimension mismatch error. That's why you always want to clear out your data list first. And 45.2. All right, let's double check that looks right. And we're good. All right, now that our data is into our stat list, we can do a calculation on it. We're going to press stat again, but this time scroll over to calculations and select number 4. We want to do a linear regression. Notice now our other options are just right below that. We'll be using those in other units. Just going to press number 4. And now I can go down here and press calculate, and that's okay. You're going to get a screen that looks like this. If you've turned your diagnostics on, you're going to get R-squared values. That tells you how good a fit our line is. But we won't be talking about that too much in this unit. An R-squared value closer to 1 means a better fit. But all right, let's do that process again. But this time, I'm going to store my regression equation so that I don't have to copy it down and re-enter it into the calculator. To do this, I'm going to press bars, go over to Y bars, and then press enter, enter. Now I'm going to calculate it again. Same data. This time I got an R-squared value, very close to 1. So that's a good sign that this is a really good fit. I've got a slope, a y-intercept. You can write this down right now if you want, but it's already been plugged into your y equals. You can see they included a bunch of significant digits here. You're copying it down. Those decimals way out here aren't going to matter. All right, so does this equation that we've got here match the one on the homework? 0.438x, we've got some extra digits there, plus 8.3. So in your homework, you need to fill that in. Y equals 0.438x plus 8.3. All right. Now let's go ahead and visualize our data. We're going to do that by first turning our stat plots on by pressing second y equals, and then making sure that first stat plot is turned on. If it's not turned on, press enter, enter, and that will turn it on. Now we want to actually see the data on the graph, so I'm going to press zoom, and then 9, and that's going to zoom us to where our data is, and we'll see our line going right through it. Once again, that's zoom, and the number 9. And we can tell that we've done it correctly because we've got our data. It looks to have a positive trend, and the line's going right through it. All right, let's start answering some of these questions. Using this model, how much electricity would be consumed If the daily temperature was 61 degrees Fahrenheit, round your answer to the nearest kilowatt hour. So let's go ahead and do that. We're asking a question about what's going to happen at 61 degrees Fahrenheit. Because my equation's already in there, I can start using the table to answer questions about specific values. I could go to the table by pressing the second graph, but you can see that my table is starting at 500 and going up by 25s. That's not going to work. So I'm going to go second window and change my table. I want it to start at 60 and go up by ones. Now if I go second table, I can view the cost of 60 degrees, 61 degrees, 62, and so on. This problem asked about 61 degrees, so let's go up to 61 in our table, and we see that it's going to use about 35.033 kilowatt hours. Round to the nearest kilowatt hour, 35 kilowatt hours. According to this model, how much would be consumed if the temperature is 92? So I could scroll all the way here in my x values to 92. That might take a while. So I'm going to go back second window and just start it right at 92. Second graph, and I'm going to see that value there is 48.6. Here's kilowatt hour, that'd be 49 kilowatt hours. What temperature would I need to reach in order for 38 kilowatt hours to be consumed? Right, answer to the nearest degree. So I've got my table. I could scroll to when those kilowatt hours pass 38. And that's not going to be super difficult. I mean, we're almost there already. Okay, we just passed it. I clicked it way too many times. Go back to it. Looks like it's really much closer to 68 than 67, so we'll say 68 degrees. That's good per unit. Degrees Fahrenheit. This equation here, I didn't ask a question about it, but what does the slope represent? Well, for each degree warmer, we can expect to use about 0.438 more kilowatt hours. What does the y-intercept represent? That even at a temperature of 0, while we're well off our data, we'd still burn 8.3 kilowatt hours. That one doesn't make as much sense in the context of this problem, but that is what that means. One thing I'd like to point out here, when we made this prediction here, we interpolated. Because we're within our data, we have data about temperatures warmer and colder than 61. But when we made this prediction here, we don't have any data that is warmer than 92. I threw my arrow to the wrong number. We extrapolated. This is outside of our data. All right, let's practice this with one more. Let's see, these all just ask for interpolations and extrapolations. Let's do one that's going to have easier numbers to enter. I guess number 2 is not horrible. It'll take a little while to enter these numbers, but that's all right. We'll get to see the process one more time. For number 2, with the help of scientists, farmers in the Philippines have been able to produce more and more grains per hectare each year. Here are the crop yields for several years. Got to get that data into our calculator. So I'm going to go stat, enter. I've got data on my list, so I clear it out. Get in this list over here, clear it out. Start entering our data, 1964. 69. All right. All right, with all of our data entered, it's time to do our calculation. We press Stat again, go over to Calculate, select number 4. Store my regression equation in bars over, enter, enter, and press Calculate. Now, if your calculator doesn't give you that input screen, you have to pass those arguments through manually by opening up a parentheses and then doing second 1, comma, second 2, comma, bars over, enter, enter. You got to do all of that after your calculator says Lin Reg up here, but before you press enter the first time. Then you put all of this in afterwards, and then you press enter, and it works out. All right, let's take a look at our data. Stat plots are turned on. I press zoom 9. Looks pretty good. According to this, well, okay, let's double check we got the right equation. 41.3 is our slope. That looks right. Let's see if we got the matching y-intercept. We're looking for 80,200. Let's see, or negative 80,200, 80,239, a couple extra significant digits here. According to this model, was propagated in 1995. Second window, 1995. Second graph, take a look. There was 2,250, that'd be kilograms per hectare. So 2,250. Let's figure out what's going to happen in the year 2022. Go straight there. Uh, 3367 kilograms of food per hectare. And then this model indicates that a crop yield of 1,700 was achieved in what year? Let me show a possible technique for this. I know that this is going to be interpolation because it's within my data. So I'm going to go to y equals and plug in a horizontal line at 1,700. Now let's take a look at this graph. All right, because I put in that horizontal line to figure out the year, I just have to figure out where this intersection is. There's a function for that under second trace. Number 5 is intersect. Then you just have to press enter, 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 and it tells you that this intersection here is at 1981.69 and our y value of 1,700. So we'll say 1982. That would be CE. And we finished that problem. All right, hopefully that was helpful, and you have a good rest of your day.